Exponents confuse a lot of students, but they all follow just a few simple rules. Today, I'll show you the fastest way to simplify any exponent, even negative and fractional ones. What is an exponent? An exponent tells you how many times a base multiplies itself. For example, if we have 3 to the power 4, the base is 3 and the exponent is 4, meaning we multiplied 3 by itself 4 times. So 3 to the power 4 becomes 3 times 3 times 3 times 3, which is equal to 81. Here are the 6 essential laws of exponents. These fundamental rules help you simplify any exponential expression quickly and accurately. First, the product rule. If we have a to the power m times a to the power n, this can be written as a to the power m plus n. So in other words, you can add exponents while multiplying the same base. Then we have the quotient rule. If you have a to the power m divided by a to the power n, this can be rewritten as a to the power m minus n. In other words, you can subtract exponents when dividing the same base. Next is the power rule. If you have a to the power m raised to the power n, you can rewrite this as a to the power m times n. In other words, you can multiply the exponents when raising to a power. The power of a product. If you have ab raised to the power m, you can distribute the exponent and rewrite this as a to the power m times b to the power m. The power of a quotient. If you have a divided by b, all raised to the power m, you can apply the exponent to both numerator and denominator. So this can be rewritten as a to the power m divided by b to the power m. And finally, the zero exponent law. Any base to the power of 0 will equal 1, except that the base cannot be equal to 0. So if you have a to the power 0, that will always be equal to 1. Here's the first example. We want to simplify x to the power 3 times x to the power 5. So clearly, if we have the same base here, x, we can apply the rule and add the exponent. So this will become x to the power 3 plus 5, and we know that 3 plus 5 is 8. So our solution is x to the power 8. Now, what if we have y to the power 7 divided by y to the power 2, or y squared? Here we can see that is the quotient rule that will need to be applied because we're dividing by the same base, y. So we can subtract the exponents. 7 minus 2 is 5. So our final answer, we keep our base y, and that will be y to the power 5. Now, what if we want to rewrite or simplify 3x squared all raised to the power 4? We'll need to apply the power to each factor. So it will become 3 to the power 4 times x squared to the power 4. So 3 to the power 4, we saw in the beginning that was equal to 81. And in order to compute x squared raised to the power 4, we will apply the power rule and multiply the exponents. So since 2 times 4 is 8, our final answer will be 81 x to the power 8. So remember, when raising a product to a power, apply the exponent to each factor separately, then multiply the exponents on variables. Let's talk about negative exponents. If you have a to the power negative n, this can be rewritten as 1 over a to the power positive n. So negative exponents create reciprocals. The base moves from numerator to denominator or vice versa, and the exponents become positive. Some people refer to it as flip the base. For example, if I have 5 to the power negative 3, I can rewrite this as 1 over 5 to the power positive 3. And 5 cubed, we know it's 5 times 5 times 5, which is 125. So my final answer will be 1 over 125. Or similarly, if I have x to the power negative 2 over 3, my 3 remains in my denominator, but I could rewrite that x to the power negative 2 as x squared in the denominator. So that will become 1 over 3 x squared. Now let's simplify an expression with negative exponents step by step. We have 2x to the power negative 3 over x squared. So this is a quotient. Our 2 remains, but x to the power negative 3 divided by x to the power 2, we can use the quotient rule in order to solve. So it will become 2 times x to the power negative 3 minus 2 because we have x squared in the denominator. So this becomes 2 times x to the power negative 5 because negative 3 minus 2 is negative 5. Now we can rewrite our negative exponent, and that will become 2 divided by x to the power positive 5. Always rewrite your final answer with positive exponents unless instructed otherwise. This is the standard mathematical convention. And if you like what you see so far, please like and subscribe so you never miss a new upload from our channel. Now, how about fractional exponents? Here's the basic form. If we have a to the power 1 over n, you can rewrite this as n root of a. So in other words, the denominator n becomes the root index. The general rule is as such. If you have a to the power m over n, this is the equivalent of the n root of a to the power m. So the numerator is the power, m in our case, and the denominator is the root. For example, if I have 16 raised to the power 1/2, well, this is the same as square root of 16. We don't usually write the 2 for square root. And we know that square root of 16 is 4. Or if we have 27 raised to the power 2 over 3. So we know that 2 will be our power and 3 will be our root. So this is the equivalent of cube root of 27 squared. And the cube root of 27 is 3. So that is 3 squared, which is 9. So fractional exponents are just another way to write radicals. And understanding this connection can unlock powerful simplification techniques. So here's an example. We want to simplify 81 raised to the power 3 over 4. So first, let's interpret the fraction. The denominator is 4, which means fourth root. The numerator is 3, means cube the result. So first we can find the fourth root of 81, which is 3, because we saw at the beginning that 3 to the power 4 was 81. And then we can raise 3 to the third power. And 3 times 3 times 3 is 27. So you could also compute 81 cubed first and then take the fourth root, but usually finding the root first will give you a smaller number to work with, so it becomes easier. Understanding the relationship between exponential and radical notation is crucial for advanced algebra. For instance, if I have negative half, x to the power negative 1/2, we saw before that we could rewrite this as 1 over x to the power positive 1/2, which is the same as 1 over square root of x. 5/3. We know that x to the power 5/3, where 5, our numerator, is our power, our denominator 3 is our root. So we can rewrite this as cube root of x to the power 5. Or for instance, if you have negative 2/3, 1 over x to the power negative 2/3 is the equivalent of x to the power negative 2/3. Sorry, that was 1 over x to the power 2/3 is equal to x to the power negative 2/3. Or you could rewrite this as 1 over cube root of x squared. So let's see now an example with fractional exponents. Here's a problem. 4 x to the power 3/2 over 2 x to the power 1/2. So here's a solution process. First, we need to divide the coefficients. So 4 divided by 2 is 2. Then, since we have x to the power 3/2 in the numerator and x to the power 1/2 in our denominator, we'll need to use the quotient rule. And that is, we'll subtract the exponents. So 3/2 minus 1/2 is simply 1. So simplifying our answer, this will be 2 times x to the power 1, which is simply 2 times x. So when working with fractional exponents, make sure to find a common denominator before subtracting. In our case, we had a common denominator of 2, so it was easy to subtract 1/2 from 3/2. So let's put it all together. Now we want to simplify x to the power negative 2 times y cubed over x to the power 1/2 all squared. So let's simplify what's inside our parenthesis first. We have x to the power negative 2 times y cubed over x to the power 1/2. So since we have the same base x and x in our numerator and denominator, we can use the quotient rule in order to simplify. So that will become x to the power negative 2 minus 1/2, because we have x to the power 1/2 in the denominator, times y cubed. So y cubed remains. So negative 2 minus 1/2 is negative 5/2. So inside our parenthesis becomes x to the power negative 5/2 times y cubed. Now we need to square that. So in order to square, we will use the power rule. That is, we will multiply the exponents. So x to the power negative 5/2 squared, if we multiply our exponent, negative 5/2 times 2 is negative 5. And y cubed squared, if we multiply exponent, that will become y to the power 6. So we can rewrite our answer with positive exponents. Since we have x to the power negative 5, this becomes 1 over x to the power positive 5, and our y to the power 6 remains in our numerator. So our final answer is y to the power 6 over x to the power 5. So this problem combines quotient rule, power rule, and negative exponents. You just need to take it one step at a time. Here are your fast-track exponent rules. So first, if you multiply the same base, you will add the exponent. If you divide the same base, you will subtract the exponent. When raising a power to a power, you will multiply the exponents. If you have negative exponents, you can move the base to the opposite part of the fraction and make the negative exponent become positive. You can rewrite fractional exponents as radicals. The denominator is always the root and the numerator is the power. And any non-zero base to the power 0 will always be equal to 1. So now here's your challenge problem. I want you to simplify completely 3 times x to the power negative 3 halves times y to the power 4 over 6 times x to the power negative 2 times y to the power negative 1. So first you'll need to divide the coefficients. 3 divided by 6 is 1/2. You'll need to subtract the exponents on x because we have the x variable in the numerator and in the denominator. You'll need to do the same for the y variable because we have y variable in the numerator and in the denominator. And then simplify and write your final answer using positive exponents. So please comment your answer in the comments below. You now understand every exponent rule, even fractional and negative ones. So thanks for watching. Please like and subscribe. And don't forget, math success starts when you stay on the fast track.